One of the ways to factor is to use guess and check. When you're doing guess and check, the thing to remember is that when you're factoring with a trinomial, that you want these two numbers to multiply to this number, and you need these two numbers or variables to multiply to this one, and then you need this product and this product, these two add together to give you this middle part. So that's the idea behind it. What you're undoing is you're undoing multiplying polynomials. So it's really a division process when you're factoring. The very first thing you should always check for when you're factoring is the greatest common factor. So do v squared, 12v, and 27 have anything in common? They do not. So now I want to look at 27. Well, I know 27 is 3 times 9. So if I look at 3 times 9, that gives me 27. So the 3 times 9 gives us our 27. So then, to get to v squared, I know that I can multiply v times v to get to v squared. So v times v is v squared. So then if we check our product that we need to do, this product and this product, so this gives us 3v, and this gives us 9v, and if I add those two things together, that gives us 12v. Right? So now the only thing I need to do is look at my signs. I like to look at my signs at the end. I know in order to get to 12 with 3 and 9, I need both of them to be positive. I always like to double check at the end and make sure that these two things with our signs multiply to this value. So positive 3 times positive 9 is a positive 27. Remember, there's a couple of rules to keep in mind when you're looking at this. A positive number times a positive number is positive. So since this is positive, I know both of these will be positive, or you could have both of them be negative, right? And then if they have this is negative, then one of them would have to be positive and one of them would have to be negative. Okay? So I'm going to factor out and then that's it. That's our answer. So this is our factored amount. Then, if we look at the next one has a common 2. So notice we always check for a greatest common factor. So between 2v squared, 30v, and 100, we have a common 2. So I'm first going to take out the 2. Remember, when you're taking out the 2, you're really dividing. So 2v squared divided by 2 is just v squared. 30v divided by 2 is 15v. And 100 divided by 2 is 50. All right? So then I'm thinking, what multiplies to 50 but adds to 15? Or I'm just thinking of factors of 50. So I know, I went on autopilot. The v and the v multiply to the v squared, right? If I look at 50, now please make sure that you're looking at this number and not at the 100, because if you're looking at the 100, that's before we factored out our greatest common factor. So you always want to make sure that you're factoring out or you're looking at the one after you had factored out the number. So if I think of 50, I can do 25 and 2. Right? So if I do 25 and 2, so now if I check these, 25 times v is 25v, and v times 2 is 2v. So then if I add those two together, that gives me 27v, which notice is not 15v, so it can't be those two. So I erase. This is why this is called guess and check, because you're guessing and then you're checking. Okay. And then as you get faster, or as you do more problems, your guessing and checking gets quicker. So I know two numbers that multiply to 50 and add to 15 would be 5 and 10. So then when I go to check, this gives me 5v, this gives me 10v. If I add those two things together, that gives me 15v. So then I again like to check my signs at the end. You can do it before then, but this gives us positive 5, positive 10. That gives me positive 15, which is what the middle sign is, and then that 5 times 10 gives me positive 50, which is what the 50 is. So then your full answer is the 2v times 5 times v plus 10. Okay. So that's our next example. If we look at the next one, this one gets slightly more complicated because notice here there's no common factor. We don't have 2n between 2n squared and 9n and 9. There's no common factor. Okay, so notice that we still have a number other than 1. So previously we had a 1v squared here and we had a 1v squared here. So we have to take into consideration that too. So when we do guess and check, now normally in our guess and check we've had where this and this is just our v squared, or in this case it would be an n. But in order to get to 2n squared, I need something that multiplies to 2. So the only thing that multiplies to 2, but it's whole numbers, is, sorry, not squared, is n and 2n, or I could have put 2n and n, right? So these two things multiplied together give me the 2n squared. Okay. Now, if we look at 9, I know there's two things that multiply to 9. I've got 9 and 1 and 3 and 3. So I could put those options in there. Okay, so if we look at, let's do 3 and 3 first. So if I look here, this product gives me 6n. If I look here, this product gives me 3n, which notice does add to 9. So 6n plus 3n equals our 9n, which is this one. Okay. I need, in order to get to 9n, I need both of those to be positive. In order to get to 9, I need both the 3's to be positive as well. Okay. Now, if I had checked, just so you can see, the 9 and the 1 perhaps, this would give me 2n, and this would give me 9n, and 2n and 9n, I could either get to, if I do 2 plus 9, that gives me 11n, if I do 2 minus 9, that gives me 7n, or if I do, you could make it so that you could have positive or negative of either one of these. So, but that's not my middle number that I'm trying to get to, right? So then I would have erased those options, and then I would have tried the other option, okay? So then if we look at our next one, again, you want to check for a common factor. So all of our numbers are even, so I have a common factor. So if I think of 10, we've got 5 and 2 and 10 and 1 that go into it. 1 won't be your common factor unless you have a negative, then maybe you would think of -1 being a common factor. I always like to have my positives at the beginning. Okay, so for example here, if we take out the 2, oh, I neglected to say the common factor is a 2. So if we take out the 2 that's in common, notice I start with the small number. So 2, 5, 10, and 1 are the factors of 10. So I know that 2 goes into 72 and 2. I know that 5 doesn't go into 72. And I know that 10 doesn't go into 72. So then I know my common factor is 2. Okay. So then we have 10p squared divided by 2 is 5p squared. 72p divided by 2 is 36p. And 72 divided by 2 is 36. Okay. So again, I like to, for guess and check, make my sets of parentheses, so don't forget to keep the 2 or your common factor out in front. There's only one way to multiply to 5 with whole numbers, so we've got 5p and p. And it's always really nice when this front number is a prime number because it makes it easy to find your numbers. Okay, for 36 we have quite a few options available to us, right? So we're trying to get to 72, so let's just do 6 and 6. So if I do 6 and 6, this gives me 6p, this gives me 30p, which gives me 6p plus 30p, which gives me 36p. So that, and then I make sure that my signs can work. I need both of these to be positive, both of these to be positive. So then I end up with 2 times 5p plus 6 times p plus 6. And then this is my answer. Okay? Now, I'm going to show you a different one that has a minus because there's not one of those yet. Okay. So here, again, our front number, our ax squared value is prime, so that means that this would be 5x and x. Okay. For 21, we don't have a lot of factors, which is great. So if I check 21 and 1, I do 21x and 5x. Well, that doesn't work. I could also switch these around, so those two change places. So the 21 was here, so the 1 can go here, and the 21 can go here. Well, this will give me now a 1x, and then this would give me 105x, which is too high to get to my 32. So that doesn't work either. So then I'm going to look at, okay, well, I did my 1 and 21, so now let's look at 7 and 3. So if we look at 7 and 3, we've got 7 x, and then we've got 15x. Well, if we do 7 plus 15, that gives us 22, or I could go smaller, but we're trying to get to 32, so that's not quite enough. So I need to switch and go the other direction. And then, of course, I just forgot. I think the 3 was over there. Oh, yeah, because there's a 7x. Okay. Struggles. Okay, so then we have 3x and 35x. So then, if I need a negative 32, I need the 35 to be negative and the 3 to be positive. So to make the 3 be positive, I need this as a plus, and then I need this as a minus. I double check this last sign. Positive 3 times negative 7 really is a negative 21. So then this becomes my answer. Let's try one more with a negative. Let's do 10x squared minus 64x minus 42. Okay. Again, the very first thing you should check for is a common factor. So if I look for a common factor, these all have a common factor of 2. If I think of 10, which is my small number, I could also look at 5. 5 doesn't go into 64 or 42, so it's not going to be that, and 10 doesn't go into 64 or 42, so 2 is going to be my common factor. So if I take out a 2, we've got 5x squared minus 32x minus 21. Okay? So then I'm going to set up my parentheses so that I can do guess and check. So this first number is prime, so I know I'm going to do 5x and x. Oh, and then this was the same problem. Go figure that I would do that. So that's not helpful. Let's try one more. Sorry. If we do 9x squared minus 88x minus 20. Okay. So here, when I do guess and checks, now for 9, I have either a 9 and 1 that I could use, or I have a 3 and a 3. So we have 9 and 1, or 3 and 3, right? But for 20, we also have a lot of options as well, right? So for 20, we've got 1 and 20, 2 and 10, 4, 3 doesn't go to, then 4 and 5, and then those are all of our options, right? So if I've got 9 and 1, so I'm going to start and go methodically with 9 and 1, and then let's pick 1 and 20. So if I do 1 and 20, this gives me 1, this gives me 180, which is too big. If I switch it around, and this is 20, and this is 1, then this gives me 20, and this gives me 9, which isn't 88. So 20 and 1 aren't going to do us any good with 9 and 1. We'll hold, and maybe we'll have to get to the 3s and 3s. So then I am going to erase these ones. So then if I try 2 and 10, right, this gives us 2x, this gives us 90x. Oh, look here, I can get to 88, but we want a negative 88, so I need 90 to be negative, and then I need 2 to be positive. So to make 90 negative, I need to make the 10 negative, so it's 9 times negative 10 to get to negative 90. To make the 2 be positive, I need this as a positive. Then I double check my signs at the very end. Positive 2 times negative 10 really does give me negative 20. Okay? Now, if I kept going through and it didn't work, I would have tried, if the 9s and 1s didn't work, to do 3 and 3. So this is the downfall for guess and check, is that when you get higher values and more composite numbers, that it can be time consuming to check all the different factors. But that is how you can do the guess and check way.